You are listening to The Vocal Technologist. Spoken tech for your ears.
I was sitting there the other day just waiting for my coffee machine to heat up, and I had a bit of a realization.
Oh, yeah. What did the espresso machine tell you?
Well, I was honestly just trying to prompt engineer it to make a decent flat white. But it got me thinking, the tech industry absolutely loves to run in circles.
Right. We do tend to reinvent the wheel every few years.
It is genuinely like watching a greyhound chase a mechanical rabbit, except the rabbit is made of venture capital and the dog runs on electricity.
That is a terrifyingly accurate visual, actually. What brought this on, though?
Well, think about the trajectory we have been on. We
Yeah.
spent the last 10 years obsessed with automation.
Oh, absolutely.
We built low-code platforms, no-code tools, drag-and-drop interfaces. We did everything short of telepathy to avoid writing actual code. We wanted to get as far away from the terminal as possible.
Right, the whole democratization of development movement. The goal was to build software without actually building software.
Exactly. And now, fast forward to right now, and we are throwing massive parties celebrating just how much raw code we can generate with AI.
It is hilarious. We are swinging the pendulum back, but with a completely weird twist.
We have gone from code is a liability to look at this absolute mountain of syntax I just prompted into existence in record time. It feels completely ludicrous.
We aren't writing it by hand, but we are certainly drowning in it.
Yeah.
It is less about craftsmanship now and more about sheer volume.
So that is what we are going to unpack for you on The Vocal Technologist. We are going to strip back the hype and look at the actual state of DevOps right now.
And honestly, it is a bit of a mess.
A fascinating mess, but a mess nonetheless. We have got AI trying to take the wheel infrastructure, frantically evolving to hold up that AI, and some very human lessons learned the hard way.
It is a chaotic mix of silicon and psychology.
It is. And look, I am just here trying to prompt engineer my coffee machine while you are the one who actually reads the documentation. So let us get into it.
Let us do it.
I want to start with something that honestly made me do a double take. There is a metric making a comeback that I thought we successfully buried in the late 90s. Lines of code.
Ah, yes. The zombie metric. It rises from the grave.
It really has. I am seeing reports where teams are pointing at massive code volumes as a sign of AI success. Like, look, we generated 1 million lines this sprint.
Which is incredibly dangerous. I cannot stress this enough for anyone listening who manages a team. Volume measures absolutely nothing of value.
It is like measuring the quality of a novel by how much the book weighs.
Precisely. In fact, the age of LLMs, large language models, if you are seeing massive spikes in code volume, that usually correlates with duplication.
Right.
It means churn and false productivity. Just because you have more code does not mean you have more features or better stability. You likely just have more technical debt.
Because AI models are trained on the internet, and the internet is verbose.
Spot on. They repeat patterns.
Yeah.
If a human writes a function in 10 lines, an unrefined AI might do it in 30 just because it is probabilistically generating tokens.
So if we ignore the volume, what should leaders actually be tracking? If I am a CTO, what is on my dashboard?
You need to look at the downstream effects. Track time to value, track code durability.
Meaning how long that code survives before someone has to rewrite it.
Exactly.
Yeah.
And track defect rates. But the really big one right now is team comprehension.
Comprehension. As in, do they actually understand what the AI wrote?
Yes. If your team does not understand the code the AI pumped out, you are in serious trouble. When that code breaks at 3 in the morning, can the on-call engineer fix it? Or are they just staring at a black box generated by a robot?
That is a scary thought, handing over the keys to something you do not understand. But surely it is not all bad. I saw a counterexample that I absolutely loved.
The Azure Quick Review story.
Yes, they used GitHub Copilot, but they did not use it to add more bloat.
This is a fantastic case study, actually. So the Azure team used Copilot Plan and Agent modes to refactor their internal tool.
Can we pause there for a second? What do you mean by plan and agent modes?
Good catch. So rather than just using autocomplete where the AI guesses the next word like it does on your phone, they use the agentic capabilities.
So it is more autonomous.
Right. They gave the AI a high-level goal. They said, analyze this entire architecture and look for redundancies. The AI acts less like a typist and more like an architect.
And the result was not more code.
No. They ended up removing over 16,000 net lines of code across 560 files.
16,000 lines deleted.
Yep. They deleted major technical debt and got rid of 72 scanner packages.
And what did that do to the performance?
Scan performance improved by 90%.
90%, that is huge.
It is. And it proves that the best use case for AI in development right now might not be writing code at all. It might be deleting it, simplifying the architecture.
I reckon negative lines of code should be the metric we are celebrating. If you can delete code and speed things up, you get a gold star.
I agree completely. Less surface area for bugs.
But it is not all smooth sailing with AI, is it? We are seeing some pretty stark numbers regarding AI Insight Reliability Engineering, or SRE.
We are. The data shows that over 50% of AI SRE proof of concepts get abandoned.
Over half.
They just never make it to production.
That is worse than a coin flip, considering the amount of money involved in these proof of concepts. Why is the failure rate so high?
Well, it comes down to misaligned expectations.
Yeah.
About 80% of AI projects fail generally. But in SRE specifically, the issue is often the environment itself. Most of these PPs run in sandboxes.
Safe spaces. Clean data.
Too safe. The tool learns in a pristine, controlled environment. It is like learning to drive a car in a completely empty parking lot.
Right, and then you merge onto the highway.
Exactly. You throw it into the chaos of a real production system with network latency, messy logs, weird customer data, and it just chokes. The learnings do not transfer over.
So how do you fix that? Do you just stop doing proof of concepts altogether?
No, you just change the scope. There is a really interesting criterion that suggests POCs scoped under 3 months are 3 times more likely to actually reach production.
Why is that? Is it just about momentum?
Momentum and focus, yes. If you spend a year building a PPAS-C, the underlying technology has probably changed twice before you even finish. You need to prove value quickly in a real context, fail fast or succeed fast, but do not drag it out.
Keep it tight. I like that. Now, speaking of moving from sandboxes to the real world, let us talk about the big buzzword of the moment, Agentic DevOps.
Sounds like a Secret Service operation.
It does, doesn't it? Agentic DevOps.
Yeah.
But essentially, we are seeing a shift. We used to rely heavily on deterministic CI/CD pipelines.
Right. Deterministic meaning if X happens, then do Y. It is a script. It is very rigid.
Exactly. If the tests pass, deploy the code. If the CPU is high scale, up the server. But Agentic DevOps is moving toward AI-driven judgment.
We are talking about tools like the Microsoft Azure SRE agent or the new GitHub Copilot capabilities.
And these are not just following a static script anymore. They can autonomously debug tests, remediate incidents, and theoretically reduce toil.
And that is exactly where things get fascinating and a little bit terrifying.
You were playing the skeptic for this one.
Someone has to. Look, the capabilities are impressive. But these tools introduce completely opaque decision-making. In a deterministic pipeline, if something breaks, you can trace the script and see exactly why it happened.
Line 42 failed.
Exactly. With an AI agent, you do not always know why it did what it did.
Black box problem.
Spot on. This creates novel failure modes. You are handing over operational risks to a system that does not think like a human. It operates on probabilities.
Which means it might guess wrong.
It might decide to restart a server because it calculates an 80% chance of fixing a memory leak without knowing that restarting that specific server wipes the cache for the entire region.
Ouch. So you need really strong guardrails.
Extremely strong. You basically need to supervise the supervisor.
And it seems like we are missing a piece of the puzzle here, specifically around incident management. We have tools from PagerDuty or Datadog that are great at diagnosis, right? Finding the problem.
But they are not managing the crisis.
That is the gap. Incident response is not just about fixing a bug. It is about coordination.
It is the war room aspect. When a major outage happens, you have a scribe, a commander, someone checking the database, someone checking the front end. You need multiple human perspectives to avoid fixation on the wrong solution.
And current AI agents are just solo players?
Exactly. Current single-agent systems cannot coordinate a team or manage the human side of a crisis. They cannot say, hey, hold on, we're going down a rabbit hole here. Let us step back.
It is like having a brilliant mechanic who cannot talk to the driver or the pit crew. They might perfectly fix the engine while the car is literally on fire.
That is a perfect analogy. And despite these risks, adoption is actually climbing fast. A recent Docker report showed that 60% of organizations already have agents in production.
60%? That is way higher than I expected.
It is, but security remains the top scaling challenge. People are putting these agents out there, but they are terrified of what happens when the agent gets the keys to the castle.
Well, if we are going to give agents the keys, we better have a solid house for them to live in. Which brings us to infrastructure. There has been a big update to Kubernetes version 1.35, and the community has given it a fantastic nickname.
Timbernetes.
Timbernetes. I absolutely love it. Sounds like a lumberjack festival in the Pacific Northwest. But it is actually addressing some major pain points for AI workloads.
It really is. This release is signaling that Kubernetes is positioning itself as the operating system for AI. One of the standout features is gang scheduling.
Which sounds nefarious, but I assume it is a good thing.
It is essential, actually, for distributed AI jobs. Imagine you are training a massive model across 10 different servers or nodes.
Yeah.
You need all those resources to be available at the exact same time.
Right, because they have to talk to each other to do the math.
Exactly. If one node starts and the others are not ready, that first node just sits there waiting and wasting incredibly expensive GPU time. It is like booking a restaurant table for 4 people. You do not want 3 people sitting there for an hour waiting for the 4th person before you can order.
Gang scheduling ensures the whole game of resources starts together.
Right. It is all about efficiency. They have also added stable-in-place pod resource resizing.
Unpack that for us. That means you can change CPU or memory without restarting the container.
Yes. Historically, if a container needed more memory, Kubernetes had to kill it and start a bigger one. That kills your active connections, your cache, absolutely everything.
Which is a nightmare for AI workloads, right?
A total nightmare.
Yeah.
But now, for AI inference jobs that have fluctuating demands, maybe the load gets heavy for an hour. You can resize on the fly without any downtime.
That is a massive game changer for stability. And I saw they changed the default output to camel.
Yes, anything to reduce YAML configuration errors is a huge win in my book.
Amen to that. Now, speaking of expensive GPU time, the hardware side of the cloud is evolving too. DigitalOcean has launched something really interesting, an inference-optimized image.
This is a really concrete example of hardware and software tuning working together perfectly. They managed to run the MetaLlama 3.370B model, which is an absolute beast of a model on just 2 H100 GPUs instead of the usual 4.
That is a 50% hardware reduction. And considering those H100 chips cost about as much as a luxury car, that is significant money saved.
Huge money. And the performance actually went up. They achieved 143% higher throughput and lowered costs by 75%.
Okay, how do you double the speed while having the hardware? Is it just magic?
It is extreme optimization. They're using techniques like speculative decoding and flash attention 3.
Okay, we need to define those. Start with speculative decoding.
Think of it like a very smart autocomplete for the GPU.
Okay.
Instead of the main massive GPU calculating the next word one by one, which is slow and expensive, a smaller, much faster draft model guesses the next few words. The big GPU then just verifies those guesses in a batch. Verifying is infinitely faster than generating from scratch.
Ah, so it is skipping ahead and checking its work. What about flash attention 3?
That is all about memory management. Usually a GPU wastes a lot of time moving data back and forth between its memory and its compute cores. It is like walking across a massive warehouse to get one box at a time. Flash attention reorders the math, so you do more work with the data while it is already loaded in the core. It completely reduces the commute time for the data.
So we are not just throwing more raw power at AI anymore. We are getting significantly smarter about how we use the power we have.
Exactly.
Which is incredibly good news, because as smart as our machines are getting, we humans still have a remarkable knack for messing things up. I want to talk about a recent incident at Cloudflare that serves as a bit of a cautionary tale.
The outage on February 20th.
Yeah, a classic case of automation gone wild.
It really was.
Yeah.
It was not a malicious attack, and it was not a hardware failure. It was just a buggy API query in an automated cleanup task.
An automated janitor effectively swept up the wrong dust.
A lot of dust. So they have a system to clean up old IP address routes. But the query they wrote for the API was way too broad. It unintentionally withdrew 1100 prefix standards. Bring your own IP prefixes.
That is the BYOIP system.
Right. That is about 25% of all their BYOIP writs globally.
That is absolutely massive. Suddenly, customer services are completely unreachable. The 1.1.1.1 website is throwing 403 errors everywhere.
And it happened fast. That is the double-edged sword of automation. It allows you to operate at an incredible scale, but when it breaks things at an incredible scale instantly.
Right. If a human were doing that manually, they might have deleted 5 routes and realized something was weird and stopped.
Exactly. But the script just nuked 25% of the network in seconds.
It is a really good reminder that even the biggest tech players trip over their own shoelaces sometimes. But I want to contrast that fast catastrophic failure with a story of slow, painfully slow persistence. The RuboCop Marathon.
300 days of RuboCop. This is a story for the engineering purists.
It really is. So we have a developer introducing linting, specifically Rubocop, into a massive legacy Rails monolith. We are talking over 1 million lines of code.
And for those who might not know, linting is basically an automated spell check for code style and syntax errors. Doing that on 1 million lines of 10-year-old code is usually a complete nightmare. Most people would try to do a big bang migration.
Run the tool, fix everything at once, merge it, and pray.
And most people would fail. The development team would revolt because the merge conflicts would bring the entire company to a standstill. But this developer took a totally different approach. Incrementalism.
Hundreds of small reviewable pull requests. Instead of overwhelming the team, they just chipped away at it day after day.
And it worked beautifully. It reduced review friction, and it actually uncovered real underlying bugs that are hiding in the messy code.
It forces us to rethink that whole move fast and break things mentality. Sometimes, especially with legacy technical debt, it is move slow and fix things.
It is the difference between a sprint and a marathon. In a code base that size, patience is a legitimate engineering skill.
Absolutely. Now let us shift gears and look at some new tools and technical curiosities that caught our eye. First up for the database nerds out there, PGBeam.
This is a really clever tool. It is a globally distributed PostgreSQL proxy.
So what is the actual pitch for using it?
Latency. Physics is the ultimate enemy of the cloud. If your database is sitting in Virginia and your user is on their phone in Sydney, the speed of light limits how fast that data can travel back and forth. PGBeam sits right in the middle. It routes connections to the nearest edge location and actively caches the select query results.
So it is the database reads closer to the user.
Yes, and the benchmarks are showing 3 to 5 times faster response times in distant regions.
And the beauty of it is you just change your connection string, right? You do not have to re-architect your entire application or set up complex read replicas manually.
Exactly. It completely abstracts the complexity of geodistribution away from the developer.
That is super handy. Now here is one that genuinely makes me scratch my head a bit. Git in Postgres.
This falls squarely into the category of just because you can does not mean you should. Or maybe you should. I am still undecided.
Unpack it for me because I am confused.
It is exactly what it sounds like. Someone implemented the Git object and reference model directly inside a Postgres database.
So instead of a hidden .git folder on your local disk, the commits are literally rows in a database table.
Effectively, yes.
Yeah.
It allows you to run complex SQL queries over your commits and repository trees. You can literally run select all from commits where author is me. It unifies your storage, your application data, and your version control data live in the exact same place.
That sounds incredibly heavy, though.
It is extremely heavy on storage. You lose the efficiency of the standard Git compression, which is highly optimized for text files. But for certain enterprise use cases, maybe strict auditing or specific regulatory backups, having that SQL query power and unified backup strategy could actually be compelling.
I reckon I will just stick to the command line for now, but it is definitely a cool concept. Finally, a quick nod to the future of the web. WebAssembly, or WASM.
WASM has been the future for a while now.
It has, but there is a big update on the component model.
Right. So WASM allows you to run code from languages like Rust or C++ directly in the web browser at near native speed. But currently, if you want to use WASM, you often need a fair bit of JavaScript glue code just to make it talk to the standard browser APIs.
Which kind of defeats the purpose of trying to escape JavaScript in the first place.
Somewhat, yes. It is messy. The component model aims to allow direct integration with web APIs. No JavaScript glue required. It basically standardizes how WASM modules talk to the outside world seamlessly.
So it significantly lowers the barrier to entry.
Exactly. It is a real sign of maturity. WASM is moving from a cool academic experiment to a solid foundational part of the web stack.
Love to see it. It is always fascinating to watch these foundational technologies evolve in real time.
It really is.
So let us wrap this up. We have looked at a lot today. We are building much smarter infrastructure like Timbernetes and highly optimized hardware to run these AI agents that are starting to write our code and manage our operations.
But we are also seeing clearly that volume is not value. Just because an AI can write 1 million lines of code does not mean it should. And automation without strict oversight, like we saw in the Cloudflare case, can be absolutely disastrous.
And we still desperately need humans to spend 300 days fixing the linting errors or figuring out why the AI just deleted the wrong IP addresses.
It raises a really important question for you to think about. As we move rapidly toward this agentic DevOps world, where AI manages the pipeline and writes the code, are we the engineers becoming the bottleneck? Or are we actually the only safety net left?
That is something for you to chew on while you are waiting for your next build to deploy. Catch you next time.
See you later.
Spoken Tech for your ears.